last lesson we're going to do before we take a break and do a test over like the trig stuff. And as I said, we'll go back and look at graphs. But lesson 4A is solving problems with trig. These are some of your real-world applications, looking at measurements, connections. We've done a little bit with this, I feel like, already. I can't remember where it was, but back when we were first talking about reviewing our SOHCAHTOA and stuff, we did a little bit with this, so I think it'll be somewhat familiar. A little bit of vocabulary first. Angle of elevation versus angle of depression. Okay, probably words you've heard, probably something you have a pretty decent idea of already. The angle of elevation, the angle through which the eye moves up from the horizontal to look at something above. So when we talk about angle of elevation, that is, if I'm standing here on the ground, looking up at the top of a building, okay? Looking up at the top of a lighthouse. Looking, you're looking up. So when we talk about angle of elevation, that is the difference, the angle between the horizontal, so the ground, and the angle my eyes are looking up, so my line of vision. Okay? So, whatever that angle is, the difference there. So that's angle of elevation. Angle of depression, the angle through which the eye moves down from the horizontal to look at something below. This is more along the lines of you're standing on top of a building and you're looking down. Okay, so this is, if I'm standing on top of the building, there's the horizontal. The angle my eyes make with that horizontal, my line of vision as I look down. So it's that angle from the horizontal up there. Okay, so I'll show you a picture of exactly what we're talking about there when we get to an example. But those are the vocabulary to be familiar with here. Okay, so example 1, the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse 130 feet above the surface of the water is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. What am I going to suggest? Yeah, okay. Draw a picture of some sort, right? Needless to say, we're talking about our trig stuff. It's going to come up to be a right triangle somehow or another. You just have to get it there. So, we have the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse. So, the lighthouse, you're going to get my, you guys can draw the fancy lighthouses, but here's what's going to represent the lighthouse for me. Okay, there's my non-fancy lighthouse. And then a buoy. You guys know what a buoy is, right? The floating bobbing thing out on the water. So I'm going to make this dot my buoy. What? Did it describe it? It's usually marking something. Depends. I say that, it could be marking like, okay, this is the no wave zone. I'm thinking you have to idle your boat. Once you get past this marking, you have to idle your boat. It could be marking this is a swimming area. Don't bring your boat in this swimming area. It could be marking, this is a rocky area. This is shallow. You don't want to be in this area. I don't know. Yeah. So, as I said, it's the floating bobbing thingy. It marks lots of different things. So, it depends on your scenario. Okay. So, angle of depression of a buoy from the top of the Barnegat Bay Lighthouse. Notice 130 feet above the surface of the water. So, that 130 feet is the height of the lighthouse. And then angle of depression, the idea here is, here's the horizontal I'm comparing with. My angle of depression is in relation from the horizontal down to my line of sight. My line of sight is that diagonal I just drew. So realize, where is that angle of depression? Whoops. 6 degrees here. So that 6 degrees is actually going to be outside of my triangle, if you realize what's happening. Okay? Won't be a huge deal. We'll fix it here in a moment. Find the distance x from the base of the lighthouse to the base of the buoy. So we're trying to find the bottom of the triangle. And obviously, I created a right triangle. Are we okay with the picture? Okay. So, I have a 6 degrees, I have 130 feet, and I'm trying to find x. What's the connection I need to make for this to work? Okay, figure out other degrees inside the triangle. What are ways we can do this? Okay, the little angle by the buoy is going to be the same as the angle of depression. You guys remember your geometry rules that tell you that? Because officially that's a geometry rule there. If two parallel lines are cut by a transversal, then those would be alternate interior angles are congruent. Does that sound familiar? That's what I remember from my geometry, but that's been a few. Okay. So, if you didn't realize that those 6's were going to be the same, what's the other thing you could have done? Yeah. We know this is going to have to be a right angle here with the horizontal and the lighthouse. And so that would make, if you subtract here, that does make this 84 degrees. And then if this is 90, this is 84, that leaves 6 degrees there to make your third angle in the triangle. So honestly, it's easiest just to know that if this angle outside is 6, then this angle inside is 6. Okay. How do I find x? Technically, we have options, but tan of 6 degrees is going to equal what? Because I agree. Okay. Tangent of 6 degrees equals 130 over x because of SOHCAHTOA. Tangent is opposite over adjacent, so that's 130 over x. We did something like this previously, didn't we, where we had to solve for x when we were first reviewing SOHCAHTOA? What do we do here? Yeah, that's 130 divided by x. Let's multiply by x. So I multiply x over, it's x times the tangent of 6 degrees equals 130. To get x by itself, I'm going to do x equals 130 divided by tangent of 6 degrees. Grab your calculator and try it. I'm going to throw Holden's question at you guys. What mode do you have to be in? Doesn't matter. How do I know I have to be in degrees? Okay, we were given 6 degrees, yes? So you have to be in degrees. Is it going to matter? It will. If you're in the wrong mode, you will not get the right answer. Okay. Yeah. The difference of, whoops. I have the exact same thing typed, but got 2 totally different answers. Now, is that negative an indicator that we might have done something wrong? Or we're in the wrong mode? Okay, so, yeah, if they give you degrees, you need to be in degrees. If they don't give you degrees, you need to be in radians. Okay, so this is a distance, x, so I have 2 decimal places on mine. So 1,236 and 80, 736.87 feet. Okay, questions on that? You got the setup? I mean, getting the picture and the setup's the hardest part, and I don't know, to me that one's not a hard problem at all. So you just have to know the setup. Okay, let's try B. Example 2. From the top of the 100-foot tall Altgett Hall, a man observes 46 degrees during the period of observation. How far does the car travel? So, of course, I'm going to draw a picture. This time I have the 100-foot tall Altgett Hall. Oh, you're going to be so surprised. There you go. So shocking, I know. There. And as far as I'm concerned, you can just draw a triangle and that side is the hall. So, now, let's see. We know that Altgett Hall is 100 feet tall, right? And it says, so from the top of the hall, so here's my horizontal, if that helps. A man observes a car moving toward the building. So what we've got here, we've got a man observing a car way out here. But what's that car doing? Yeah, it's driving towards the building. So this car is going this way, going this way, going this way, and then what happens later? First he observes the car at 22 degrees, then he observes the car at an angle depression of 46 degrees. So he observes this car at two different places. So we just formed not one, but two triangles. Obviously, we have the right triangle there. What was the first thing they gave us when he first observes the car? Not when he first. When he first, the angle of depression, it changes from 22 to 46. So the first time he observes the car, has an angle of depression of 22 degrees. Which, what does that mean? If it's 22 up here, this piece right here is 22 degrees. Then, the car moves closer to him. And now, what is that angle now? Now he's got an angle of 46 degrees. So that means this angle right here is 46 degrees. That's a 46 up there in the corner that you can't read. Sorry. It's mostly important to be able to read it down here. What is it that we're being asked to find? How far the car travels. So we're being asked to find this entire distance, which I'm going to call y. You can call it whatever you want, but I'm going to call y. Wait a minute. No, we're not asked to. Yeah. I just labeled that. I totally backwards that. Okay. The question is, how far does the car travel? Did I label how far the car traveled? Is that what y really is? I was thinking ahead to another step. Where does the car travel? But from the time he's at 22 degrees to the time he's at 46 degrees. So what we really need to find, sorry, I was thinking ahead here, is this distance right here. I'm going to call that x. Now, if you can tell I'm thinking ahead because I know where this problem is going. Can I find x as is? Is x the side of a right triangle? No, x is not the side of a right triangle, so does trig work? Not directly. So what are we going to have to find? You can find the entire y, and we can also find what? This short distance. And once you find the long distance and the short distance, you can subtract them. Do you see where I'm going with that? So pick some letters to label. I'm going to call this side on the 46 degrees. I'm going to go with what I have in my notes, which probably came from the book. I'm going to call that D for distance. So let's start with y. How do we find y here? If y is the distance from the car's original position to the hall. How do I find y? You could do that. I'm personally going to keep them with the big 3, but I'm not going to argue you couldn't do that. Okay, Daryl said cotangent of 22, which he's saving himself a step if you don't mind doing cotangent on the calculator. Okay, because cotangent, instead of being opposite over adjacent, is going to be adjacent over opposite. So that means he would be doing y over 100. So he would end up doing 100 times the cotangent of 22. Do you guys remember how to do cotangent on the calculator? Okay, it's tangent of 22 and you raise it to negative 1 power. And I'm perfectly fine with that. Okay? What's the other option if you'd rather avoid the cotangent? You can do tangent, right? And I'm guessing some of you guys will go one way, some of you guys will go the other way, and that's fine. If we do tangent, tangent of 22 has to be 100 over y. The difference here is we end up dividing to get our answer, right? So, your choice. It's an individual choice. Make sure you meet me at the end with a correct answer. That's what I'll say. So I'm going to say tangent of 22 is 100 over y. Can you guys do this in one step in your head at this point? If it's 100 divided by y, I have to multiply the y over. Then I'm going to have y times tangent of 22, which means I'm then going to have to divide. So are you okay if I say that y is 100 divided by tangent of 22? I'm willing to go there if you guys are. Okay. I mean, technically it's not just switching, but yet, I get it. It is, you know. Understand why we just switched them. That's what I will say. Okay. Calculator answer. Sounds right. Now, for mine, is this going to be a final answer? No. Be careful how you round, which, if I give my final answer in 2 decimal places, I would suggest you take more than 2 decimal places with you. I'm not saying you have to go all the way here. However, honestly, when I go to get my final answer, this is still on my calculator screen, isn't it? I'm not going to retype it in. I'm going to use the one that's on my calculator screen. Okay, what's the next thing I have to do? I found y. I now know the distance from where the car started all the way over to the hall. What else do I need to find? Or what else can I find? The distance from where the car ended to the hall. In other words, at this 46-degree angle. So that's going to mean what? Tangent of 46 is equal to opposite over adjacent, 100 over d. Or you could have said cotangent of 46 degrees equals d over 100. So if I multiply the d over to the tangent and then divide by the tangent, d is 100 divided by tangent of 46 degrees. And so I'm doing 100 divided by tangent of 46. Did you guys get what I got? A 96 number. So 96.568877748, so on and so forth. Am I done? No. What do I need to find to be done? I need to know what x is. And how do I find x? Subtract them. It is y minus d. So if I do y minus d, which I'm all about, okay, there's y on my calculator minus, there's d on my calculator. I didn't retype in a single thing. If I give 2 decimal places, I've got 150.94 feet. If you remind me at the end, I can check the answer key. It is possible the answer key is only going to 1 decimal place. Actually, no, I take that back. The answer key is mostly 2 decimal places for tomorrow. So, okay. So that's your harder type problem where you have to set up the 2 triangles and figure out the connection there. Not impossible by any means, but again, this is, how we can use our trick. One more. It says find theta. Yep. So my question to you guys right now is, what is the connection? Realize theta is an angle, yes? What connection can be made between the theta, the 62, and the 25 they give me? That's a tangent connection, yes? Because based on this angle, from in relation to the angle, I know the opposite and the adjacent. So I'm going to set up the equation. Tangent of theta equals, what did we work with in lesson 4.7? That's when we worked with the inverses, okay? And we worked with the inverses. We could say, okay, it was like tangent inverse of this is equal to what angle? Remember, the answer to a tangent inverse is an angle. So if the answer to a tangent inverse is an angle, or the answer to any inverse is an angle, and I need to find an angle, I can take the inverse. Remember, an inverse just flip-flops your x and y. It flip-flops your input and your output. So we can flip-flop this. An inverse I can flip-flop. The tangent inverse of 25 over 62 is equal to theta. So by taking that inverse, that allows me to flip-flop, and now do you have something you can plug into your calculator? Yeah. We've been in degrees this whole problem, so you can leave your answer in degrees. Besides the fact, if you give a radians answer, it's not going to be anything that's going to make a whole lot of sense to you. So if I leave it in degrees, now, how do I do a tangent inverse? That's the second function, right? So that means my -1 is right there in degrees. If your calculator was in radians, you'd say whatever it is, radians. Okay, guys, your homework is on page 393, 1 through 16, 19 through 24. I expect to see some equations set up. I expect to see some pictures where necessary. I'm not saying pictures are necessary on every problem, but, this is trying to understand the word problems. And sometimes they provide you the pictures, so pictures definitely won't be as necessary there. So I'm sure there'll probably be a few we'll need to talk about tomorrow to, nothing else, understand what their pictures are looking like. But 393, 1 through 16, 19 through 24.